Hello, my name is Karen Grace Davis, and this is my Unit 2 presentation, which is a mapping demonstration. So the first step is determining the grouping / crossover categories, and here you can see a table of the data set provided, which had the gene and offspring ratios, and I went ahead and totaled the overall offspring ratio numbers, which was 5,742, and that will be important to use later on. We can first start by identifying the non-crossover group, which is abbreviated as NCO, and we can determine that by finding the highest two values that are in close proximity to one another, and the total for those two values is 2,702. Then I went ahead and um, identified the double crossover DCO group which is the two lowest values in close proximity to one another, which was 100 and 140, and I totaled that to be 240. And then we can identify the last two groups, which are both single crossover groups, and the lower SEO group is highlighted in orange here, which is 400 and 420 with a total of 820. And then the other SEO group was 970 and 1,010, which totaled 1,980. And that's highlighted in green. And then step 2 is determining the gene arrangement. And to do this, we'll need the NCO group and the DCO group, which is highlighted here. And on the left, you can see how we utilize the NCO group, DCO group to determine the correct gene arrangement. And basically, we want the DCO group to match, or we want the NCO group to match the DCO group when the double crossover occurs. And I went through the three possibilities, as you can see in the left photo, and we wanted a +A+ match or a B plus C, and I matched to +A+, and that rearranged the genes to B, A, C. And then next we use that to correct the gene arrangement. Essentially on the left side of this photo, you can see the original data set given and all of the groups and the original gene arrangement. And on the right, you can see the corrected gene arrangement where we moved the A into the middle column. And then essentially you have to rearrange everything from the previous arrangement to match in each column. And so I did that for every single group. And then the next step is to determine the distance between the genes. And to do this, you'll need all of the total values for each group, and you'll also need the overall total to do this. And essentially, you will divide the group values by the total values, and then multiply that by 100 to get the percents for each group. And then we can use the single crossover groups to find the crossover between B and A, which I used a line to show how I determined that. And then the crossover percent between A and C, and I drew another line to show how I determined that. And then now we add the DCO percent, which was calculated to be 4.2%, to our other SEO percents to find the two distances. And then here you can see for B to A, I found it to be 18.5 map units, and from A to C, I found it to be 38.7 map units. And then step 4 was calculating the coefficient of coincidence, and we have to utilize our previous data and calculations to do this, and we also need to put everything into decimal values and not percents in order to calculate the coefficient of coincidence. And first we need to calculate the DCO expected, and we do this by multiplying the decimal values of the B to A distance and the A to C distance in order to do so. And I found that to be 0.0716, which is equivalent to 7.16%. And then we can use the equation for the coefficient of coincidence to calculate C. And we use the observed DCO as well, which was 4.2%. If you remember from my previous slide, divide 4.2 by 100 and we get 0.042. We put that on the numerator, divide by the expected DCO, and I calculated that to be 0.587. And this should say step 5. It would be calculating the interference. And we use the equation below to find the interference. I equals 1 minus C. So I subtracted 0.587 from 1, which equaled 0.413, and that's our value for the interference. And we can conclude that there is positive interference with 41.3% more DCO double crossover occurred than expected. So thank you for listening to my presentation, and here's a reference for the photo.